Okay, so last topic we learned about reflections and we learned about rigid transformations. Another rigid transformation is a translation. So just a few letters different than transformation. This is translation. And all a translation is essentially a slide. A translation is noted using a big old capital T, and then instead of parentheses, we use, it's kind of like a vector notation, and vectors are line segments that have both a magnitude and a direction. So this is just a way of saying you're going to move both in the X and the Y direction in the same movement. That's kind of what a vector does. So this is vector notation. The X here tells me how I'm going to move left and right. So it goes this way for X, and then for Y, it's up and down, just like always with ordered pairs. So we're going to do the translation of this figure, EFG, to its new figure, the image and the pre-image. So this is our pre-image, EFG, to its new figure, E prime, F prime, G prime. Remember, prime just means that image instead of the pre-image. So the way it's going to look is we're going to have the translation. So we're going to find the translation 5, -3 of triangle EFG. And it's going to look like that. So again, this one is our left and right, while this guy is our up and down, just like it is in regular old ordered pairs. So the 5 tells me I'm going to move points E, F, and G 5 units to the right, and the -3 says I'm going to move it 3 units down. So first, let's make a table with our ordered pairs. So these are our original ordered pairs. This is our pre-image. E is at the point -5, 4. F is at the point -1, 5. And G is at the point -2, -1. So we're going to translate each of these points 5 units to the right and 3 units down. So for example, on point E, I'm going to move it 5 units to the right. So 1, 2, 3, 4, 5. And then I'm going to go 3 units down. 1, 2, 3. And I've got a new point right here. So that would be my E prime. Then I'm going to take F and do the same thing. I'm going to go 5 units to the right. 1, 2, 3, 4, 5, and 3 units down. That's going to be my F prime. So it's helpful to record those ordered pairs over here. So E prime is 0, 1. F prime is 4, 2. Now G prime, I'm going to do the same thing. I'm not going to draw the line this time because we really don't need that. I'm just doing it since I'm teaching. So we're going to go 5 units to the right. 1, 2, 3, 4, 5, and 3 units down. 1, 2, 3. And that is going to land us at 3, -4. So G prime is 3, -4. Okay, so here is our translated image. So again, this guy over here, pre-image. This guy over here is the image. These are rigid motions, and so it doesn't change the shape or the size to slide and move it around. This here is just a really nice, fancier picture done in Desmos so that we can see, again, that pre-image. So remember, this guy over here is the pre-image. It's what happens before. And then my primes, that's my image. Okay, so this again, this was a translation. This was a translation of 5, -3 of triangle EFG. All right, now sometimes we're going to be given 2 figures and we're going to be asked to find out what the translation was that occurred in order to make that figure from the pre-image to the image. So we're just going to find the change in y and the change in x on each of these figures. So we're going to start with our S, T, U, and V, the green image, and we're going to move to the red image, S prime, T prime, U prime, and V prime. So we can make an ordered pair, we can make a chart, or we can really just look at this and kind of count over and up. So if I start at T, start at S, and I'm going to move from S to S prime. Well, that means I'm going to go to the left one, and then I'm going to go down 1, 2, 3, 4. So I'm going to go down 4. I can double check that that works for everything else. -1, down 4, -1, down 4, -1, down 4. And so I write this transformation as a transformation of -1, -4 of S, T, U, V. Again, this is a rigid motion. It preserves the size and the shape of the image and the pre-image. The next thing we'll talk about is the composition of transformations. So when we compose transformations, we apply multiple transformations to a figure. Okay, so we're going to try an example of composition of functions. And to do this, we're going to compose two reflections. We're going to make a rule about a translation when it is two reflections. So there's a rule about how to do how to turn a double reflection into a translation. So let's first read over our problem. First thing it says is suppose that n is aligned with the equation y equals 4. Okay, so then we go down here and we look at our composition of functions and we see that it says r sub n. So this n right here merely means that that's where y is equal to 4. We're given a triangle with vertices A, which is 2, 0. So if I go over here and mark 2, 0, B is 6, 0, and C is 2, 5. Okay, so those are my 3 points. They're in our picture there. We want to know the translation of the image equivalent to this double reflection. So the first thing, again, remember, we do this in kind of a backwards order. We do this guy first, and then we do this guy second. So the first thing we're going to do is just reflect this image on the x-axis. Now, that's really easy to do, right? Because all I got to do is A and B stay in the same exact position. So I just take A and make it A prime, and B becomes B prime. And the only thing I really have to move is my C. My C is 5 units away from the x-axis, so I'm going to flip it down 5 units, and it's going to go right here, C prime. And then I'm going to connect my dots. Okay, and that is my reflection. That's my first spot, the reflection on the x-axis. So there's a nice pretty one from Desmos of showing that that's our reflection. So this guy right down here is just the reflection on the x-axis. That's our first step. The second step is I have to reflect over the line y equals 4. Well, where is the line y equals 4? So I've got to look for that on my graph first. So my y equals 4 is here. We go up 1, 2, 3, 4, and then we draw our line right there through 4. So that's y equals 4. Now I'm going to reflect this red image down here over the line y equals 4. So I'm going to reflect it. So the distance has to maintain between the line y equals 4 and points A prime, B prime, and C prime. So A prime is 4 units away from the line of reflection. So this distance right here is 4 units. So I need to go 4 units on the other side, and that's going to be my A. We'll call it double prime. Same thing with B prime. B prime is 4 away. So I'm going to go 4 to the other side, and I'm going to call that B double prime. Now C is even further away, right? So let's do a different color. C here is 5 plus 4 units away. So it's going to have to go 5 plus 4 more to the other side to get C double prime. So that would be my final shift right there. All right, so here's a nice, pretty little picture that I drew in Desmos. It shows our line of reflection here. This is y equals 4. It shows our first flip, so there's our A prime, B prime, and our C double prime, our C prime. That's our reflection across the x-axis, or the x-axis right here. Then we're reflecting it across the line y equals 4, and that guy is right here, y equals 4. And when we reflect that guy, this becomes A prime, or A double prime, B double prime, and C double prime. Now, if we look at our original image to our final image, here's our original image. That's our pre-image. And then our final image is this guy right up here. That is the same thing as translating this guy right here up 8 spaces. Up 8 spaces. So you're like, what? Let's double check that. So here's A, and here's A double prime. That is 5, 6, 7, 8. This is 8. This is 2, 8. And my original point was 2, 0. So it was a translation up 8 units. Okay, so what does that mean? Well, let's look at the distance that we have between the 2 lines of reflection. All right, so here's my x-axis. This is my first line of reflection. Here's my second line of reflection, y equals 4. The distance between those 2 lines is 4 units, right? 1, 2, 3, 4. There's 4 units. So to find the translation, we double the distance. So 4 times 2, that's 8. And then we translate it that many units based on whether we're reflecting vertically or horizontally. If we are reflecting vertically, then it is a change in y, and we move it up or down based on that change. If we're reflecting it horizontally, so it's a change in x, then we would reflect the x variable. So here's our rules. Step 1. So we find the distance between the lines of reflection. Now step 2. Step 2 is I double the distance between the 2 lines of reflection. So my original distance was 4, and then I double it. 4 times 2 is 8. That's what I did here. Third step, translate it. If it's y equals, we're going to change the y value. And if it's x equals, we're going to change the x value. And so our final translation here, our final answer would be a translation of 0, 8. That's it.